All right. So
us many times, and they've been caught
no,
doing
this
so.
should be here.
So we do discredit a lot of the stuff that they tell us to be fact when it comes to what we live on. But I'm not going to deny it. I will use it to show you how it actually ignore them. As looking into this, they say we deny stuff from space agencies.
Now, see, you look at this here. It's quite obvious. They say those turbines are a lot closer than those turbines there, and yet those are a lot lower. Look how much lower they are, even though like hard to see, but you can see the blades there, and the blades on the other ones here, and yet these are a lot lower, a lot lower. That's like half the height. Like that's it's less than half the height of this one here. But yet it's you can't say oh it's angular resolution or stuff like BS that Nico was claiming because this is why is it so much lower? Like that should be in the water. If this Earth is flat, then that is sinking. And that one they're sinking as well. And these ones here aren't. But yet they're all you go there and they're all the same height.
We don't deny everything. We just know that they have lied to us
They deny everything.
many times, and they've been caught doing so. So we do discredit a lot of the stuff that they tell us to be fact when it comes to what we live on. But I'm not going to deny it. I will use it to show you how it actually proves the opposite of what they say. I took a screenshot of these wind turbines that appear to be hidden behind curvature. And you can see that the one that is nearest the viewer, there is more of it showing, and the ones that are further are hidden quite a bit. Even the propellers are dipping down behind the curve. That
Yes, because it's behind the curve. Yeah, thank you.
is exactly what I would have thought seeing this, and it's pretty convincing to your average person that that's curvature causing you to see this phenomena. But thankfully, some researchers took some repeated observations, and not only did they see curve like this vanishing at different times, they noticed that things weren't adding up with how objects that are closer to us were smaller than the objects that were further, even though in reality they are the exact same size.
You're looking at the fact that they're angled differently there. You can see how these ones here, you can see more of the front there, and these here you can see more of the side. So we're looking at the fact that all these turbines may not be facing exactly the same way. They're trying to catch the wind and trying to get the wind at maybe different angles, so you can capitalize more on certain angles with some of these on some ways, and then certain angles in other ways. Right? They're trying to catch the wind to generate electricity with the most efficiently as possible. So yeah,
This proves that there is magnification going on, and
no, it doesn't all look the same. You can see even then these here they look the same. It's just you're talking the lights hitting one's at a certain angle here, and then you're not getting quite the same light hitting that. So that's all that is. He's talking bullshit.
most of us, including me, were not aware that such magnification was happening to the degree that it is, nor what it would do over a flat surface if it was indeed magnifying. And what would be magnifying to this degree? We know there's water in the air, but how do those water droplets do this? It's because these water droplets in the air act like a lens.
Yeah, it have to be uniform though, and to get magnification, you have to have a certain amount of bend to it. So I'll show you here. I know where he's going with this.
And they do a good job of magnifying distant objects. And when you repeat this over a flat surface with a lens that replicates this effect,
Yeah, if you notice that there, I'll show you right here. They have the lens. This is the top of the table. This is the side, and so they have this lens drop down halfway below the table. So you're gonna have there's a table here, and they're gonna put the lens. Here, this is my camera. Here's my lens. They have it sitting like that, right? So we don't observe stuff buried in the ground. We have it up here. Now I've done this exact same experiment because they try to prove this, but I've done it with my camera sitting on the surface, like if it's standing on the ground, like we do, and then I moved something away, and it didn't drop below. It didn't do what they're having here because that's not how we observe things. This is disingenuous flat Earth bullshit they try to do to manipulate and deceive people.
You can see here that the exact same phenomenon happens, and you have
Yes, because your lens is below the fucking side of the table there and pointed up slightly.
objects seemingly vanishing over a curve just like this.
And there they have a lens in front of it to that actually manipulates the opposite way. Um, there's a name for it. There you go, diverging lens. So this is what he's using there. Is something like this, right? So it's a concave lens. So, and you'll see that if I can show you here. Back to the one. So what he's showing here is this lens here is shaped like that other one, right? So it goes small in the middle, and it'll give this effect, but that's not how the atmosphere is. We don't. It's not. And then what they do is they'll put it kind of halfway down, so that it's thinner at the bottom, and then thicker at the top, and then they put it halfway, and then see how they have it. They'll have it here, and they move it back, but they're trying to manipulate stuff. But that's not how the water molecules and stuff like that are acting. But yeah, so that's kind of what it's doing is you get different lenses, diverging lenses, concave lens, biconcave, and it will cause certain objects to do stuff. So you've got convex lenses, which what it does, it focuses everything into the middle, right? Now he's trying to say that convex lens, which is like what would be like a magnifying glass, magnifying is happening, right? So thin on the outside, thicker in the middle, right? And it takes all the light and focuses it into one point, right? And then that's how you're getting something big, and it's focusing in, so it's taking all the light in. They're having this, and then they're claiming that and what it does is it causes the objects to, as it moves back, it's diverting it out, and it's making it look like it's something setting on a flat surface. All it's doing is it's just moving down as it's moving back. It's the optics, and they're trying to deceive you. Is what they do, and this is a very common trick with flat earthers. That they try to do this to try to prove their point, but that's not how the atmosphere is, and that's not how water droplets randomly all over the place would not cause that, because there's no uniformity to them. It's like um you know just like water and different humidity in the air over water or anything else. It's going to be all over the place. So if that was the case, those things be wobbling and working all over the place, which is what you see when you have like refraction and stuff like that. Is that it's dense or medium, and then coming up, it's moving all over. You have a high refractive rate, high atmospheric disturbance, and yeah. So then it warps and bends it. It doesn't stay nice and uniform like that. So he's talking crap, because all those wind turbines were not being distorted by the atmosphere at all. We weren't getting that atmospheric distortion. That's bullshit. So this is a very common tactic done by flat earthers who try to deceive and hope that people don't look into it.
Welcome to Lecture Online, and now we're going to look at some new type of lens called the diverging lens. So we're still in the set where we talk about mirrors and lenses, and especially thin lenses, but the diverging lens is something unique because in this case, when you have lines that are parallel to the normal that shine through a diverging lens, that will of course diverge the rays of light, but the way they will diverge is as if they came from the focal point in front of the lens. So anytime a ray comes through, just draw a line from there to where the ray goes to the lens, and then the ray will then continue along that path, hence the name, the diverging lens. So if we now place an object in front of that lens, and for the first example, I put the object beyond the focal point of the lens, in front of the lens, where will the image appear? And again, we're going to use our techniques, and here's my blue pen, the techniques to figure out where the image will be. We draw our first ray from the top of the object, again, parallel to the normal, just like we've done with all the other lenses. And then we realize that the ray will diverge as if it came from the focal point in front of the lens here. Like so. So this is ray number 1. Ray number 2 is through the focal point, but since this is a diverging lens, the focal length is a negative focal length. Therefore, the focal length is a negative 25 centimeters. So the focal point of interest would be the one back here. So we want to try to draw a line, a ray line from here to this focal point right there. And when we do that, of course, we get to the lens, and instead of continuing to the focal point, it will diverge, and that will continue then parallel to the normal beyond that point. And that will be ray number 2. And of course, we need a little eyeball right here because the observer will be on the other side of the lens. And looking back, seeing those two rays diverging, obviously they're not coming together forming an image on the right side of the lens, but the brain kicks into action and says, oh, I know where those rays are coming from. The number 1 is coming from over here, number 2 is coming from over here, and where those two lines meet right there, that's where the brain will put an image. And so the image will appear right over there. Now, let's go ahead and use our equations to figure out where the exact location of the image is. Again, we use the same.
So even though the image is higher up there, because of how the rays are being bent through here, it thinks it's down here. So this is manipulation that flat earthers have got onto to try to make it look like their sun is setting. But it's not. The atmosphere is not a diverging lens.
Equation S.
Remember, he claimed that this magnification. This would not be magnification.
S prime, that's the distance to the image, is equal to S times F, that's the distance to the object and the focal length, divided by S minus F. And plug in the numbers that we have. Let's see here. S is 50 centimeters, and the F is a minus 25 centimeters. Remember, for a diverging lens, the focal length is negative, divided by 50 minus a minus 25. And so this will give us, let's see, 1,250. That would be a minus, divided by 50 minus minus 25 would be a positive 75. And, let me grab my calculator, what is that equal to? So we have 1250 divided by 75. And yes, indeed, that would be a minus 16.7 centimeters. And so you can see here, if the focal point is 25 centimeters away from the lens, you can see that the image is about that distance. And so we found S prime here, S prime, of course, is going to be a negative 16.7 centimeters. Negative, of course, means that it's in front of the lens, and therefore that makes that a virtual image. So I is virtual, because it's in front of the lens, it's not a real image. And of course, that's indicated by the negative sign in front of the image distance. Now, the magnification, M, is equal to minus S prime over S. So it'll be minus a minus 16.7 divided by S, which is 50. And that looks like it's about 1/3. Yes, it is. So that would be a positive 1/3. 1/3 means that it's 1/3 the size of the object. And the fact that it's positive means that it's in the same orientation as the object, therefore it is upright. And that's how we find the image with a diverging lens.
As you just pointed out, it'd be 1/3 the size. So it's not magnification. So that here, and what they're claiming, the only way to get that to work, it actually falsifies his claim. Like I said.
Buildings, the sun will set, all of these things happen. And as you can see here, when there's less moisture in the air, things don't magnify as great, and even sunsets look a bit different.
See, that there is a sunset, and as it's going down, it's going through more atmosphere, and there's haze here. As you can see, this actually it's not clear, it's haze. And so it's blocking more and more light, and you're getting more, you're seeing less of the, so all you do is it's blocking it down to like what a solar filter would be. you're getting less of that brightness of the sun. It's being blocked more, and you're getting less glare off the sun. So when it's higher up, you got less atmosphere, you got less haze and stuff in between you. So you got more glare off the sun. As it's setting down, you're seeing less glare. And as I said before, with the solar filter, where you don't see where the sun actually looks smaller, when you have a filter, which filters out all the glare compared to the moon, you can see the sun is actually smaller. Um, it's it appears the same size because you're getting kind of glare, the same kind of glare through the atmosphere.
It's one of the reasons we love.
But if you had a solar filter the whole time, that sun would not have changed angular size, and this has been proven many times. With photographers putting on a proper solar filter and then measuring it. If you don't believe me, look at Dave McKeegan just done one. I think he did 26 hours time lapse following the sun he was in Antarctica in December. And you can see the the sunspots on it. You can actually see them moving, and you can also see the sun does not change angular size at all in 20. I think it's over 24 hours. It was. They tracked the sun with a equatorial mount. They never changed size once.
Going to the beach because that sun, as it's setting, looks so large, and you can actually stare directly at it.
Yeah, don't stare directly at the sun. That's how you destroy your freaking eyes. And as far as it looking large, it's only because when you have a point of reference, we have something to look and you can see the size compare it to, then you can see the sun looks big. Same thing with the moon. But if you actually held up like a coin or say the moon high up, and then if you're able to follow it all the way down or measure it, you'd see that it doesn't actually change size at all.
Because that water filters out light, similar to when you go down into the ocean. We can't study the bottom of the Marianas Trench from.
We can. Well, it's not very often. There's only a certain craft to go down there, but they are studying it.
From the surface, because light will not reach the bottom.
Also, because of the pressure of the ocean, to build a craft that can take that kind of pressure for a long time is a massive feat. If you don't believe me, look into the Titan sub that went down to the Titanic.
You have to send something down there that can shine its own light and have cameras to see the bottom. If you've ever gone scuba diving, you've probably encountered that problem. Once you go below a certain amount of feet, it gets darker and darker till eventually you can no longer see the surface or the sun that is directly above you. That's what.
Yes, because enough water is starting to bend. Light slows down, it gets bent, as it gets refracted, and eventually it's just not able to make it to a certain point. Yeah, we all know that. That proves nothing.
What happens here, that's how the sun goes down, and it's repeatable and something we can experiment with on a smaller scale. It's not easy, but you can definitely repeat that on a small scale with water or a magnifying lens of your choice and get the same results.
But there's not enough water in our atmosphere. We have air, right? There's he's talking like a little water in the air. What water? Like I said, you got some moisture in the air and over that, but that's not what he's claiming at all. Right, so examples I've took, and I've done a video on this. So this is off the south coast of Wales. I'm looking across the bay. See these buildings here. This is just a couple minutes later, going down to the beach, and suddenly all that cliff seems to have disappeared. This is due to the curvature of the Earth. Here's another example here. As I said, I did a whole video on this, and here, once again, that all that seems to have disappeared just by changing elevation. This is due to being able to see less over the curvature of the Earth as they're now closer down. Now the seas are calm. There wasn't a big tide. There wasn't big oceans, big waves or anything. So here's a video here using wind turbines. Now how come these turbines are further down and you can see less of them? The ones that are further away. But there's no kind of lensing or anything that was claimed there. So here's a wind farm. This is off of the Port Sunlight, which is just out the mouth of the Mersey River. Now as you can see, those turbines, which should be ramping up a bit and getting angularly smaller, but uniformly, you can see they seem to be dropping off further and further down. Now you can see the oceans where there wasn't big waves or big swells. That boat's completely steady. How come the ones that are way off in the distance look like they're dipping below the horizon? and it looks like the blades are hitting the ocean. You know they're all exactly the same altitudes and height off the ocean. This just proves everything I just said. As I said, here's a picture from that video. I did a whole video on this as well. And as you can see here, this disproves everything he just said. Here's another one that did a boat standing on top of some stairs, ran down the stairs, and you see less, and it wasn't because of swells.
Now that we've got that out of the way, let's look at some of the proof that we have that goes directly against such observations where we see too far and we are told that it is a mirage. And a mirage, which most people are aware, is actually an optical illusion that's caused by atmospheric conditions, especially the appearance of a sheet of water in a desert or on a hot road, caused by the refraction of light from the sky by heated air. You can see here, it looks like the sky
It's due to a pressure density, pressure variation closer down, and what you're actually seeing there is a Fermagana mirage, in which is that you have a thinner layer, denser layer, thinner layer on top, and it causes where you get that effect. That's only like saying because that's over the road, which the road is getting really hot, so it's heating the air right above it, and then the air above that is cooler, but then the air above that is a bit warmer because the sun's heating the air from above it. And that's you get that effect.
is just flowing right directly into the street. That's not what happens. It's a mirroring effect, and you can see it here where this ship appears to be upside down. This is a mirage. This right here is actually the ship. It's not a mirage. The horizon is now gone, and there is a false horizon that is closer to the view.
Yeah, it only happens in certain atmospheric conditions. It's called a Fabermacana mirage, and it's only if you have certain atmospheric conditions that where you get this.
We're right here. This is not the real horizon. The horizon will change, rise, and fall due to the amount of water in the air.
It's not. It's down to the density of the air above it, and it depends on the heat. But it's all down to you have different densities of the atmosphere as throughout the day, and it always depends on if it's being heated and cooled. That's why sometimes you'll have different observations you can see at different points. If it's like certain days, you get the right perfect conditions, or different times of day, and that's because with the densities are changing. The atmosphere is moving around.
You can see that with time lapse, where a shoreline will vanish behind what looks to be a curve, and then it'll appear again. Even the distant mountains will drop as the curve rises. Some really cool.
You see how they're all moving at different rates, and that's because with the that's just with the atmosphere, and you're having different densities at different points.
Things that all have to do with water in the air. The surface of the water is not waving like a flag. It just appears to be as these moisture levels change. That's why it takes repeated observations, and people have done that. People in this community have gone out there, thought they found curve, but came back again and saw that it was missing, and even entire lighthouses can vanish behind this curve.
Yeah, and that's why you need to know what the atmospheric conditions are when you do your observations. You need to know the temperatures and the humidity levels at the time so that you can account for that. There is actually ways of being able to calculate for that and to know what your atmospheric conditions were and how much refraction should be seen. And normally, whenever flat earthers say that we can see too far, it's because you have a perfect certain condition, but you go back another day and then those conditions are different, and then you don't see the observations that they claim proves a flat Earth, i.e., the black swan. We have uh, the oil platforms off of California. There we have Hill House and Habitat House platforms, and the one they always use is a certain one, but you can see there's a high degree of atmospheric refraction due to the all the cranes and stuff all being twisted, all bendy and wavy and stuff like that. But then there's people have gone back and taken the exact same shot for the same place, and those cranes are a lot straighter, where there's not nearly as much refraction, and those platforms appear a lot lower down. And in fact, the horizon is a lot more defined, which the other one that is used by flat Earth a lot of times. Yeah, there's actually a few different horizons. That's down to the refractive levels. It's bringing, because what refraction is, it brings things up higher. It causes light to bend down to our eyes, and if you have high refractive conditions, then things further away will appear to bring them up higher, a bit higher, and you can see a little bit further. So that's why you'll always, every time a flat earther brings up a long distance observation, I always ask, did they account for refraction? 99.9% of the time, they didn't.
And when conditions are better and drier, the lighthouse appears again, as it should if there were no curvature. Now,
yeah, but he's making claims, but yet I still have not seen any kind of evidence or measurements or anything to prove this. Like, how far was that? How high was observer? How far was the lighthouse? How high is the lighthouse? What time of day was it? What was the atmospheric index? How much none of this stuff is ever accounted for or given in any kind of flat Earth measurements, if they do any measurements at all.
that's not it. There are far more proofs that we're going to get into and that counteract this, and it's the long distance photos where we now know they are not a mirage, because when we look at them, they are right side up. And
as you see here, see how this is all twisted? These are supposed to be straight. A high refractive index here. There's a lot of atmospheric disturbances and stuff here. High refractive index. And you have a horizon there. You have a horizon there. And in fact, if you look further here, which they don't zoom in, there's actually a boat here, and you only see part of the boat, and that's because the is being twisted. Even here, that should be straight. It's not. That should be straight, but it's not. But I have pictures of this that I've put up on my page, and it shows the exact same platforms, and yeah, you can only see where my mouse is up there.
And they are from distances that shouldn't be possible on a globe.
But they work perfect if you account for the atmospheric refraction in this, which is a high refractive rate. It works perfectly on a globe. The globe can still explain this.
At their current elevation. And elevation is key, because that changes the math on the curve calculator. When you put in the elevation of 1 foot high, you should have a horizon that's a little over a mile away. But we can see things.
Yes, that's without accounting for the atmosphere that we are actually looking on through. The Flerfs love to try to keep that out.
That are over 9 miles away, and the horizon is even further than that. This is not a mirage. And
I also ask, why is it that here you have like a platform on the bottom there, a walkway? How come that is in the water, but yet this one here, it's above the water? And flat earthers tend to run away from that. They don't want to answer that because they know what the answer is.
you can tell that it's not as magnified as the wind turbines, because this oil rig looks smaller than the one that's closer. If you have the opposite effect and this one looks larger, then you're going to start seeing that magnification lensing effect come into place, and there will be a curve here. You could definitely come back on a different day when this one looks larger and see that
it won't look larger, but it will be not nearly as distorted.
That there is an illusion of curve. It's repeatable. You guys can do this yourself. Don't just take the very first image you see as proof of anything. Continue the investigation.
It's just a little hooey. I haven't seen, there was not a single evidence or proof there that they, one, that they did it themselves, or two, that they could actually prove. I mean, none of that stuff, they just make up BS stuff.
And by the way, all those rumors on the internet are fake. I'm not flat. I'm not hollow on the inside, and there's definitely no reptilians inside of me!